All right, so I want to talk about a couple of special situations when we are solving equations with variables on both sides. And the first situation is when we have a fraction that we are multiplying by using the distributive property. So we have 2/3 times 6x plus 18 equals 5x minus 6. Now, we can't be scared of the 2/3 times 6 because we're simply using the distributive property. You have to think it's 2/3 times 6. 2/3 times 6, that's 6 over 1. If you multiply straight across, 2 times 6 is 12, and that's all over 3. 12 divided by 3 is simply 4. Or we could have cross-reduced right here. Divided by 3 is 2, and 2 times 2 is 4. So we have 4x. Then we have 2/3 times 18, and we'll do the same thing again. We're just going to separate out over here. If we want to go straight across, we have 36 over 3, which simplifies to 12. Or we could have said 3 divided by 3 is 1, 18 divided by 3 is 6, and then 2 times 6 is 12. So there you have it. We have 4x plus 12 equals 5x minus 6. The thing I want to tell you is you could use middle math. You could say, act like these are both over 1 and say 2 times 6 is 12, and then 12 divided by 3 is 4. Again, 2 times 6 is 12. 12 divided by 3 is 4. 2 times 18 is 36. 36 divided by 3 is 12. Again, 2 times 18 is 36, and 36 divided by 3 is 12. And then we're all set. We'll collect our variable terms. I'm going to subtract 4x minus 4x. That leaves me with 12 equals 1x minus 6. Then I'm going to get rid of my constant terms. I'm going to add 6 to both sides. 18 equals 1x divided by 1. 18 equals x, or x equals 18. Second example of a similar type problem, I'm going to draw right here. Okay, if I had negative 2/5, 10x times 10x minus 5 equals 6x plus 10. Again, using the shortcut, we'd say negative 2 times 10 is negative 20, and negative 20 divided by 5 is negative 4x. Again, that's negative 2 times 10 is negative 20. Negative 20 divided by 5 is negative 4x over 1. Negative 2 times negative 5 is 10. Divided by 5 is positive 2. Again, that's negative 2 times negative 5 is negative 10. Divided by 5 is positive 2. And that equals 6x plus 10. Just a shortcut to be able to multiply by a fraction. We'll add 4x to both sides, so that gives me 0. And we have 2 equals 10x plus 10. We'll subtract 10 on both sides. Leaves us with negative 8 equals 10x. I know I'm going through this quickly, but we've already seen this before. Divided by 10 on both sides, and we know that we always simplify. So our answer is negative 4/5 equals x, or x equals negative 4/5. Either way works. Again, a little shortcut. If you didn't want to do that, you could have said negative 2/5 times 10 over 1 and negative 2/5 times negative 5 over 1. And that would have given you negative 4x and your 2. The next thing I want to talk about is what happens when we are going to solve a proportion with variables on both sides. If I gave you this basic proportion, x over 10 equals 6 over 5, you would say, well, the way I solve this is by cross multiplying. So we have 5x equals 60, because we know that cross products are equal to each other when you have a proportion. Then we could divide on both sides, and x equals 12. Well, the first example I want to show you is if we had something like this. X plus 5 over 10 equals x plus 4 over 7. We're going to use the same principle used here by the cross multiplying, and we're going to say 10 times x plus 4, 10 times x plus 4 equals 7 times x plus 5. Again, we're cross multiplying, but we're going to have to distribute because the 7 is being multiplied by the x and the 5, and the 10 is being multiplied by the x and the 4. So here we'll say 10x plus 40 because we distribute. And then we'll say 7x plus equals 7x plus 35. Again, I just want to show you how we distribute the 7 to both of these. We distribute the 10 to both of these. You may want to even put these in parentheses to make it a little bit easier. Once we get here, it's very simple. We want to collect our variable terms, so I'm going to subtract 7x. It gives me 0. Left with 3x plus 40 equals 35. We'll collect our constant terms. So we're left with 3x equals negative 5. This is 3 times x. We divide by 3 on both sides, and our answer is negative 5/3. Okay. Second example would be this. Let's say we have x minus 6 all over negative 3, and that equals x plus 4 all over negative 2. Again, this is a proportion, so we want to multiply our cross products. So I'm going to say negative 3 times the quantity of x plus 4. You may want to put these in parentheses. And that equals negative 2 times x minus 6. Again, we're saying x times 5 equals 6 times 10 like we did earlier this year. So we'll distribute the negative 3 to the x and to the 4. That's negative 3x minus 12 equals negative 2x plus 12. Again, we want to distribute right there. We got to be careful that we take that negative. It's negative 2 times negative 6 gives me positive 12. Let's collect my variable terms. I'm going to add 2x to both sides. That leaves me with negative 1x minus 12 equals 12. I'm going to add 12 to both sides. And be careful here. It leaves you with negative 1x equals 24. And then we must divide by negative 1 to give us our answer, negative 24. Last thing I want to show you, and this is kind of a, we'll call this a special equation. It's when all you have is a variable term on both sides. So it's when you have 3x equals 10x. Well, there are two ways to think about this. The first way, algebraically, you would say, well, how do I get my variable terms to one side? Well, if you look up here, we added or subtracted, right? We had 10x and 7x, so we subtracted the 7x. Or we subtract the other. So right here, let's make it positive. Let's subtract 3x from both sides. 3x minus 3x gives me 0, okay, because it's 0x, and 0 times anything is just 0. So 0 equals 7x. 10 minus 3x, 7x. Then we're going to divide by 7 on both sides. That leaves me with 1x, and then 0 divided by 7 is, sorry, it's not 7. 0 divided by 7 is 7. I mean, it's 0. Because if you start with nothing, whatever you divide it by, you still wind up with nothing. So x equals 0. Let's do one more example like that. Let's say that we have 6x equals 2x. Well, let's get our variable term on one side. I'm going to subtract 2x here. Okay, that leaves me with 4x equals 0. If I divide by 4 on both sides, x is 0. So what you notice is we got the same answer on both of these, equals 0 both times. Well, what I want you to do for a minute is focus on 3x equals 10x and focus on 6x equals 2x. What is the only number I could plug in for x that would make these two equal each other? Well, let's see. If x equaled 1, we'd say 3 times 1 equals 10 times 1. Well, that's 3 equals 10. That's not true. What about if x equals 2? Well, that's 3 times 2 equals 10 times 2. Well, there's 6 equals 20. Doesn't work. The only number that works is going to be 0. Because if I say x equals 0, well, 3 times 0 equals 10 times 0. And well, 3 times 0 is 0. 10 times 0 is 0. That's the only number that works. So again, when you have a variable term equals another variable term, the only number that would work if you plug in 0, so we plug in 0, so it's 6 times 0 equals 2 times 0, we're left with 0 equals 0. That's the only number that works to make each side of the equation true. I hope this helped you out today.